Okay, let's revisit this page in our notes, talking about arithmetic, geometric, and quadratic. The arithmetic form looks like f of x equals ax plus b. A is the first common difference, and b is the zero term or the y-intercept. It's linear, and the degree is 1 because we have x to the first power. Geometric, and also on arithmetic, the first differences are the same. Geometric, the form is f of x equals a sub 0 times r to the x. A sub 0 is the zero term. R is the common ratio. It's exponential. And always multiply to get the next term. Quadratic, f of x equals ax squared plus bx plus c. The zero term is c, or the y-intercept. Its degree is 2. The highest power of x is 2. And the second differences are the same. Now let's kind of walk through that. So that should be updated on one page in your notes. Now, another page in your notes, we're going to title this one Distinguishing between Linear, Quadratic, and Exponential. And then we're also going to do an activity where we find the area and perimeter. So start with first table. Add to the table, add a column. That's going to be our first differences. Now, what do you do to get from 14 to 11? What do you do to get from 11 to 8, so forth and so on? So take a moment, fill those in. Okay, those are minus 3, minus 3, minus 3, minus 3, and minus 3. Now let's add another column for the second differences. Now we only look at the first differences. What do you do to get from negative 3 to negative 3? Well, that's plus 0, plus 0, plus 0, plus 0. So as we take a look at that, the first differences are the same, and the second difference is 0. We'll come back to what type that is in a moment. Now let's do the exact same with the other two. So let's add our first differences for the next one. So go ahead and take a moment, figure out the differences. Okay, let's check those. So negative 4 to 5 is plus 9, 5 to 8 is plus 3, 8 to 5 is minus 3, 5 to negative 4 is minus 9, negative 4 to negative 19 is negative 15. Second differences, okay? Add your column, go ahead and figure out the second differences. Okay, let's check those. From 9 to 3, it's minus 6. From 3 to negative 3, it's minus 6. From negative 3 to negative 9 is minus 6, and negative 9 to negative 15 is minus 6. The first difference is not the same. The second difference is the same. Now let's do that with the third table. So add our third column for first differences. Go ahead and calculate those. Now let's check those. So plus 8, plus 24, plus 72, plus 216, and plus 648. Kind of noticing the first differences are not the same. Now let's do the second differences. So go ahead and add your column. Go ahead and calculate those. Okay, 8 to 24 is plus 16, 24 to 72 is plus 48, 72 to 216 is plus 144, 216 to 648 is plus 432. First difference is different, second difference is different. When the first difference is the same and the second difference is 0, that is a linear function. When the first difference is not the same but the second difference is the same, that is quadratic. And when the first and second differences are different, that is exponential. Now we're going to take those same and graph them. So you might want a piece of graph paper so that you can tape this in. But start with looking at the first table. Our x's goes from negative 2 to 3, so if you notice on my graph I'm going from negative 4 to 3. And our y's go from negative 1 to 14, so that's why I'm down at negative 3 up to 15. We plot the points, look at them in that nice straight line, then you draw a line through it. Second data set, notice we're going from negative 2 to 3 for the x's, but we're going from negative 20 to positive 10 on the y's. Plot the points, and this is a quadratic, so we draw a parabola through it. The last one, the exponential, -2 to 3. Notice I'm going from -5 to 10 on the graph, and then I am not graphing the whole thing. I can't. To draw a reasonable graph, I'm only going to get 4, 12, and 36 for the y's. So we plot those, and an exponential can't go negative, so it's riding above the x-axis and then runs up really quickly. Okay, so go ahead and get those in and add another page in your notes, perimeter and finding perimeter and area. And these are our two examples. So perimeter is what? What's the formula for finding the perimeter of a rectangle? Add up all the sides. So on the first one, we have y plus y. Since it's both the length and width are y, that means the other sides are y and y. So that's 4y, so we could also write that, or 4 times y, which just is 4y centimeters. That is the perimeter. On the second one, we have an x plus 4 feet for the length, plus x plus 3 for the width, and then we come to another length, which is another x plus 4, and another width, which is another x plus 3. Or we could look at that as 2 x plus 4s plus 2 x plus 3s. And let's see, 1, 2, 3, 4 x's, and then 4 and 4 is 8, 3 and 3 is 6, so we could write 4x plus 8 plus 6. 8 plus 6 is 14. And I forgot to put in that that would be 4x plus 14 feet. Area, how do you find area of a rectangle? That's right, multiply length times width. So on the first one, that's going to be y times y, which is y squared centimeters squared. The second one, that's x plus 4 times x plus 3. Well, the area model works really well for that, where we draw the rectangle 2 across, 2 down, x plus 3 across the top, x plus 4 down the front. Find the area of each little rectangle. X times x is x squared, x times 3 is 3x, 4 times x is 4x, 4 times 3 is 12. Now we add all of those interior rectangles to get the total. There's only x squared, so our answer will have x squared. 3x plus 4x is 7x, and then plus 12, and that would be feet squared. Okay, now try exercise set 3 and 4.